Hey, all you cool cats and kittens. Guess what? We are going to do our final video review for the final quiz that you will have to take this year. And it's over this last chapter, arithmetic and geometric sequences. Woohoo! I'm excited to be finished. I'm hoping you are too. So, before we go into doing any type of problem, let's go over our formulas that we learned this last chapter. We have the arithmetic sequences, and those are sequences that have the same common difference between them. For instance, if I wanted to make a common difference of 3, I would add 3 between every single term. So 3 plus 3 is 6, add another 3, I get 9, add another 3, I get 12, etc., etc. So your common difference can be a positive number where the numbers are getting bigger, but you could also have a negative difference. So if you had a negative difference, your numbers would be getting smaller as you go from left to right. The second kind of sequences that we talked about were the geometric sequences. They don't have a common difference, but they have a common ratio. So in order to do geometric sequences, you're multiplying by a ratio or a number every time to get the next term. For instance, let's say I started with 2, then I went to 8, then 32, and let's see if I can figure out what the common ratio is here. So every time you try to find a common ratio, you take a term and you divide it by the one before it. So if I take 8 divided by 2, I get 4. If I take 32 and I divide it by 8, I get 4, and so on and so forth. So our ratio in this geometric sequence would be 4, because that's the number that you're going to be multiplying by every single time to get the next term. Now, ratios can be positive numbers. You could have a negative number as your ratio, and if that happens, your sequence goes from positive to positive to negative numbers. And you can also have fractions and decimals. So if you multiply by fractions, let's say 1/4 is your ratio, the numbers will be getting smaller as you're going from left to right because you're multiplying by a fraction or dividing by 4, basically. Okay, so here's our first problem. It says describe the pattern, write the next term, and then write an explicit rule for the nth term of a sequence. All right, so the first thing we need to do is decide what's the pattern going on here. So I look at here, the numbers are 46, 36, 26, 16. So the numbers are getting smaller, and it looks like they are subtracting 10 between every single one of the numbers. That would mean that it's an arithmetic sequence if they're subtracting or adding the same number. So the common difference that I have here, so I'm going to be using this formula, is a negative 10. If I want to find the next term, I just need to take 16 minus 10, and that gives me 6. So the next term would have been a 6. Now, I'm going to use this formula right here so that I can write the rule, which basically means you have a rule that you would follow so you can find any term in the sequence. So we would say any term in the sequence equals the first term. And if I look back up here, my first term was 46, so that needs to go right here, plus, we're trying to write the nth term of a sequence, so we keep the n in the formula, but we do know what the d is equal to negative 10. So I plug in my difference right here. We're not going to use this formula at all because we're not doing geometric. Now I need to distribute my negative 10 to both of these parts. So negative 10 times n, and a negative times a negative makes a positive 10, and gather these two like terms. So a sub n would equal negative 10n, and then 46 plus 10 makes 56. So this would be the formula or the rule for finding the nth term of a sequence. Now remember that if you have an arithmetic sequence, basically if you were to graph it, that you ended up with a linear graph, and this is the linear form. This would be mx plus b, negative 10n plus 56. So we have a line because we had an arithmetic sequence if we were to graph the number of terms for every term that goes with it. Okay, now describe the pattern, write the next term, write the explicit rule for the nth term of a sequence. Okay, let's look at our pattern this time. It's going from 80 down to 20. So if we were subtracting, that would be a difference of 60. Then it goes from 20 down to 5. So if we're subtracting, that would only be a difference of 15. So that's not a common difference. So we know we're not going to be using this formula this time. So let's see if there's a common ratio. If I take 20 and divide it by the term in front of it, 20 over 80 is 1 over 4. If I take 5 and then divide it by 20, the term in front of it, I get 1 over 4. And if I take 5/4 and divide it by 5, the term in front of it, remember for division you keep, change, and flip. So these 5s will cancel out and I end up with 1/4. So you can see I got 1/4 every single time. So my common ratio this time is 1/4. It's a geometric sequence. So I'm going to be using this formula over here to write the nth term. Oh, and let's find the next term. So if we had 5 over 4 and we wanted to find the next term, we just need to multiply by that ratio. So 5 times 1 is 5, 4 times 4 is 16. So the next term in the sequence would have been 5 over 16. Okay, here's our formula for the nth term. So any term equals the first term, which if I look back is 80, times my ratio, which I said was 1/4. So here's 1/4 to the n minus 1. So that would be the explicit rule that I would use if I wanted to find any certain term in the sequence. So if I want to find the 7th term, I just put 7 in for n in both places. And that would give me, after I calculated it out on my calculator, the 7th term. Next problem. Determine whether the sequence is arithmetic or geometric, and then write a rule for the nth term. Now, we've been doing that, but this time they also ask us to find a sub 7, which means we're looking for the 7th term after we figure out what the rule is. Okay, so first of all, if I start with 147 and I notice I'm going down to 135, then down again 123, I can see that if I subtract between the two, so take 147 and take away 135, that difference is a difference of 12. So we're subtracting 12 to get to that next term. If I take 135 and I subtract 12 again, do I get 123? And looks like I do. So as long as 123 subtracting 12 gives me 111, I know that my common difference is going to be negative 12. So 123 subtract another 12 gives me 111. So my difference is negative 12. That means it's arithmetic. Now let's come up with our rule. So the arithmetic formula, I'm going to write it down here. You need to start memorizing it or looking back. So it's the nth term equals the first term plus, in the parentheses, you put n minus 1 times your common difference on the n. Okay, so I need to write this down now. The nth term equals the first term. Here's my first term of 147 plus n minus 1. And we figured out our difference was negative 12. So now we're going to distribute negative 12 times n. Negative 12 times negative 1 is a positive 12. Add our like terms together. So negative 12n plus 159 is going to be our rule. Now, last but not least, let's find our 7th term. So n would equal 7. So a sub 7 equals negative 12 times 7 plus 159. If I use a calculator, I get negative 84 plus 159. And when I put all that in the calculator, I get 75. So 75 would have been the 7th term. Okay, let's go to the next problem. Write the first 6 terms of the sequence. All right, so we're going to be plugging in the n equals 1 for the first term, n equals 2 for the second term, and so on and so forth. So a sub 1 means n equals 1, so 1 squared, subtract 1. Well, 1 squared is 1, minus 1 more is 0. So the first term in this sequence is 0. A sub 2, this time n is 2. 2 squared minus 1, that's 4 minus 1 makes 3. So the second term is 3. A sub 3, this time n equals 3. I'm squaring that in. So 3 squared minus 1, which is 9 minus 1 equals 8. 8's the third term. We're going to 6. The fourth term, 4 squared minus 1. That's 16 minus 1 makes 15. A sub 5. That's 5 squared minus 1. So 25 minus 1 is 24. And the last term, the sixth term, is going to be 6 squared minus 1. 36 minus 1 is 35. So here are the first 6 terms of this sequence. Write the first 6 terms of this sequence. Okay, this one's a little different because they tell us the first term, so we already know that our first term is equal to 6. And you can see right here that it says a sub n equals 2 times a sub n minus 1. Well, n minus 1 would mean if I have the first term, so let's say n is equal to 1, it would be 2 times a, and then n is 1. So that would be the a to the 0. Well, a to the 0 would be the term right in front of the first term. So if the first term is 6, and I had to take 2 times whatever the 0 term was to get it, that would mean my term right in front here, my a of 0 term, would have been 3. So you can see here that they're taking 2 times every term to get to the next term. So 3 times 2 makes 6. If I have the first term as 6 and I multiply it by 2, that's going to give me that second term. So that would be 12. And I just keep multiplying by 2 to get the first 6 terms. So a sub 3 is going to be 2 times the term before. So 2 times 12 is 24. A sub 4. Well, that's 2 times term before here. So that was 24. So that's 48. Got 2 more to go. Multiply by 2 again, you can see you're going to get 96. And then if you multiply that again by 2 to get the sixth term, 96 times 2 is 192. So here's the first 6 terms in this sequence. 2 times every term to get the next one. Last problem. Last problem. A marching band is arranged in rows. The first row, it says, has 3 band members in it. So I'm going to say that's the first term in our sequence we're getting ready to make. 3. Each row after that first one has 2 more band members than the row before it. So that would mean that if I have my second row or my second term, I need 2 more band members than the one before it. So 3 plus 2 will give me 5 for the next row. The third row, 2 more than the one before it. So if I take 5 plus 2, I get 7 for the third row, and so on and so forth. It now says to tell me a rule for the number of band members in the nth row. Okay, well, let's look and see here. If we're adding 2 every time, that means we have an arithmetic sequence. We know that if we add 2, that's our common difference. And here, again, is our formula. So, we're writing the nth term, so a sub n equals the first term, which we know we started with 3 in that first row, so 3 is the first term, plus n minus 1 times our difference, which we know was plus 2. Distribute, so a sub n equals 3 plus this 2 times this n minus 2. Add like terms, so 3 minus 2 makes 1. Therefore, a sub n is going to be 2n plus a positive 1. Now, if we want to find the number of band members in the 7th row, we need to let n equal 7. So in the 7th row, 2 times n is 7 this time, plus 1 will give me 14 plus 1, making 15 in the 7th row. That concludes our video review. We hope you do really well on the quiz tomorrow, and have a great summer. Bye-bye.